So hi everyone, my name is Shahir and I am joined by Josh and we are both from UTDL and today we will be hosting our 3D printing workshop. Before I hand it off to Josh, I would just like to speak a bit more about UTDL and what we have to offer this school year. So this first semester, we've had a lot of workshops and two mini events that we've hosted. And this workshop will actually be our final workshop for the semester, but next semester we'll be having some Autodesk hosted workshops going into the details of Autodesk Fusion 360, CFD, and generative design. So be sure to look out for that. We also have our upcoming Designathon next February and our Autodesk hosted Glider competition in March. So do look out for those postings on our Facebook and Instagram. So for this workshop, Josh will be going over the ins and outs of 3D printing, how you can get started on that. And if you want to follow along, Josh has created a nifty 3D printing aid sheet that you can download for yourself and follow along. And if you're interested in signing up for the raffle, we are doing a $25 Amazon gift card raffle entry. So if you're interested, please do fill in the form posted in the chat. That's it for me. I hope you learned lots from the workshop, and now I'll hand it off to Josh. Off to you.
All right, hey everybody, thanks for stopping in. So as Shahir said, we're going to be going over 3D printing today. If you have any questions at any time, feel free just to pop them in the chat there. So I'm just going to turn off my camera now so I don't overload my computer here. And can everybody see my screen here? Awesome. All right, so let's get started here. All right, so what we're going to go over today is firstly, the history of 3D printing. It's important to know the context. Then we're going to be comparing the different 3D printers you're probably going to see on your time here at U of T. Then we're going to go over some tips for CAD design, slicers, how to navigate when you're actually printing. We're going to do a demonstration on slicing a print. And then we're going to talk about our troubleshooting when we're printing, which is going to be a large part of the workshop today, because that is normally where most people run into trouble. And then lastly, we're going to talk about cleaning up and finishing off once you're done your 3D print. So a little bit of history here. So the first 3D printing attempts are granted to Dr. Hideo Kodama for his development of a rapid prototyping technique in 1981. He was the first to describe a layer-by-layer approach for manufacturing, which we see today in most 3D printers. Unfortunately, he did not actually patent this requirement. So the person who's actually accredited with the first SLA 3D printing is Charles Hull. He founded the 3D Systems Corporation and released the SLA-1, which is the first ever commercial 3D printer. So there's three 3D printers, or three main types of 3D printers that you're going to see probably in your careers in engineering here. And that's the SLA, the SLS, and the FDM. And we're going to go over exactly what those mean and what those are. So firstly, you got your stereolithography 3D printer. So this works by shining a UV laser beam onto UV sensitive resin. And when these SLA resins are exposed to certain wavelengths of light, they polymerize into solidified, rigid, or flexible geometries. And this printing occurs in a bottom-up motion. The next type is selective laser sintering. This uses a high-powered laser to fuse small particles of polymer powder into a solid structure based on a 3D model. Now, the most common type of 3D printer, and the one that you would be using in the Designathon and that are present in the MyHealth fabrication facility, is the fused deposition modeling. So what this does is it employs a spool of plastic filament, and actually now there's developments where you can have metal or wood filaments as well. And basically it's heated to be molten, and then it's ejected through an extruder onto the print platform. The extruder nozzle traces out the 3D model layer by layer while depositing the melted filament, which then cools once it's deposited. Some other key characteristics is that FDMs use bottom-up motion. They have a cooling fan, detachable print bed, and often require an SD card or USB to upload designs to the printer. So just one final comparison of when you might use them. So you might use stereolithography for functional prototyping, if you have something that's got a lot of patterns, and if you're making molds or tools. FDM is kind of your, I guess, initial step in iterative 3D printing there. It's for basic proof of concept, or simple prototyping. And SLS is for functional prototyping and end-use production. So that would be your final step if you were creating a fully 3D printed product. So a couple important CAD tips for FDM. So for the rest of this workshop here, we're going to be focusing on FDM printing because that's what you'll be using most commonly here at U of T. So it's important to avoid overhang. So as that first figure shows there, the larger an overhang, because we're depositing layer by layer in 3D printing, without support, there's nothing underneath that overhang. And so as you can imagine, that gravity is just going to bring down that molten filament before it cools. And as such, you want to limit your use of overhangs as much as possible, or use support, which we'll talk about later. You're also going to want to avoid severe bridges. So as you can see in that second image there, that it starts to degrade in the archways of each of these gaps between main pillars. That's because, again, gravity is going to start bringing down those prints before the plastic has cooled. You're also going to want to avoid chunky blocks, such as inefficient use of your filament, and considering plastic properties when you're high-end designing and optimizing. So how to actually print for FDM. So your first step is from the CAD model, whether that be Fusion 360 or something like that, you're going to want to export to STL. The STL file is what's going to be read by 3D Print Slicer software. There's multiple you can choose from, such as Kira, Simplify 3D, Slice 3R. The point of all of these is that they're going to generate G-code to be used for that the printer will read. Once you're in that slicer of choice, you're going to want to select the filament you'll be using. Some of them, for example, Kira, gives you the option of 2 different filaments that it could switch between. However, in most cases, you're only ever going to be using one type of filament at a time. So you can just select the same filament for both 1 and 2, and then you'll optimize the setting just for filament 1. The next step is you're going to want to change orientation. So the key with orientation is, again, minimizing overhang, minimizing bridges, and you're also going to try and want to minimize support because material use is important. So for example, on the far left screen, you can see if we wanted to print this U-shaped shape here, if you turned it so that it was concave down there, that's going to be a lot of support in order to deal with that top overhang. Whereas you're going to need no support for the bottom concave up U because there is no overhang. Next step is adding supports. So supports are basically less dense, less infill 3D printing pylons, basically, that will be used to print anything that has an overhang or anything like that. There's some other print settings that are important for optimizing your design. One of them is infill styles. If you're going for a speed design, something like a functional or initial functional prototype or something like that, you could probably be fine with rectangular. It is a lot faster. If you're going for something that is stronger, triangular is the way to go. As well, you can optimize your infill percentage with regards to how you want speed. Obviously, lower in percentage is going to be faster printing, higher percentage is going to be stronger. There does become a point where the higher and higher the percentage goes, it actually doesn't change the strength that much. However, it does take a lot longer. So usually 25% is kind of your highest bar or highest threshold you need to go for strength and infill percentage. Some other important settings are your top and bottom layers. These are going to be important for some of the troubleshooting we'll talk about later on. So these layers are solid, whereas all the other layers will have that infill of the triangles. These ones will be completely solid. And usually about 0.75 millimeters is about the thickness you need for those. Cura also sets the number of layers based on thickness. Some of the other ones, you'll actually have to choose the exact number of layers you want with that thickness. That's further optimization. And there's troubleshooting guides like I've attached at the end of this document or end of this presentation that will help you decide those. All right, moving on here. Temperature is also important when you're printing for FDM. In most cases, you're going to be printing with PLA, which is going to require the hot end of the extruder. So that's the part that's actually heating up your plastic, making it molten. That needs to be about 210 degrees Celsius. If you're using ABS or PETG filaments, you're going to want to do 230 to 245 degrees Celsius. Most FDM printers use a heated print platform as well. And so you're going to want that to be about 50 to 60 degrees Celsius for PLA and 90 to 100 degrees Celsius for ABS. And this varies for PETG. So again, consult the troubleshooting guides for that one. It's important, obviously, for safety that the bed and the extruder are very, very hot. So when it comes to troubleshooting, you got to stop the print first and let it cool down before you touch any of those pieces of equipment there. Right. Once you've done that, your last step is going to be, or last two steps is going to be to slice your CAD model. When you're at the slicing stage, you'll be able to view both the X-ray view and see how the support actually shows up. If it's got too much support, or if you see there's some places that the slicer isn't adding support, you can also manually add support there if you'd like. And then lastly, you're going to want to export the sliced thing, which is now G-code, which is what the 3D printer can read, to an SD card, or if it's directly connected to a machine, the desktop that you're using, you can just send it to the machine. A couple of other things to go over that are important to consider is the retraction and extra restart distance. So plastic at 210 degrees Celsius, so our PLA filament, is viscous in liquid form, and the extruder will stop extruding before a liner layer is finished to prevent oozing. So that's an important thing to keep in mind, especially during the final stage of your print there when it's laying down that last layer. As well, a couple things about retraction. During the hot end movement of your extruder, the filament is retracted to prevent oozing. So it's both, basically there's a gear inside most FDM printers, and it is pushing the filament down, but it'll also push it back up after each extrusion, which can cause clogging in some cases because it is re-extruding somewhat hot filament, which is again something to keep in mind and we'll discuss when troubleshooting later. Lastly, with regards to extra restart, before the next line and layer of a hot end movement is extruded, extra filament is extruded to compensate for oozing. So again, there's a lot of filament traffic going up and down the extrusion there. That's why it's important to optimize the temperature, because if you're making it too hot, that's going to easily clog. So that's why we recommend using, again, that 210 degrees Celsius that I discussed earlier. All right, two more settings, extrusion multiplier and cooling. The extrusion multiplier determines how much filament is extruded. Data is provided on filament diameter and hot end diameter, and usually the defaults in Cura are good enough there. Increasing the extrusion multiplier to more than one will increase the amount of filament deposited onto the print. Again, this is really about density, and if you're optimizing strength, obviously more filament is going to make it a bit stronger, but then again, do be careful about how much you're extruding, because we talked about that in the previous slide there. You don't want to cause cloggage. Cooling, the fan speed is adjustable depending on the model. You're going to want to leave the fan off for the first layer to help it stick to the platform. And we'll talk about how to make sure you can actually get it off the platform a little bit later. And you're going to want to turn the fan on during the full blast, during overhang and bridging. You want everything to cool as quick as possible, because that's going to prevent that dropping down of the filament that we saw earlier. All right. So does anyone have any questions about that? No, excellent. Okay. So I'm now going to do a demonstration of just how that's going to work. Cura Ultimaker version 4.1.12 is available for free from the link down there. You are welcome to download now to follow along. However, it's going to be a pretty quick demonstration because in all seriousness, this part of 3D printing doesn't take very long and it's fairly intuitive. So can everyone see the Cura screen I have up? Yes, excellent. Okay, so right here we have this ring. It's actually the first thing I ever 3D printed, so a little bit of nostalgia for everybody there. So the first step here, as we said, is you can go and rotate your model on the different axes here. Now, I'm going to choose this orientation here, just because I'll have the thinnest part of the overhang at the top, so I won't have to print as much overhang. In truth, this actual overhang is actually not that much of an angle, and so you could print it without support. In fact, I'll show you all the actual copy of this printed in just a moment, and I actually printed it without support. But this way, you're not going to need as much because you really just need it for the top thinnest part, so you're minimizing the risk of overhang there. So the next step is going to be to add our supports. So you want to go up to your setting here. As you notice, we've got generic PLA selected at the top here for both 1 and 2. We're only going to be optimizing 1 because we're just going to be using printers that just use the one extrusion of filament. At the top here as well, I've selected the Ultimaker S5. Obviously, it doesn't really change the settings. That's just going to be making sure that everything's aligned with the printer you're using. So as you can see, you can add as many printers as you'd like there. So adding supports here. Even though support placement says everywhere, it's actually only going to put it in the places that are optimized. So places that have an overhang angle of over 60 degrees. So I would just keep it with the everywhere option and let the program decide where it best needs support. Obviously, if it misses a place, which sometimes does happen, you can have that in there. All right, so next we're going to want to go to infill. Right now, we've got it selected on triangles. There are a lot of other choices you can do here. If you wanted to do fastest, it would be grid. We'll keep it on triangles for now. Infill density, I've set here to 20%. So right in the middle of the 15 to 25% range for some good strength on our print here. We're next going to move to the top and bottom layer. Once again, I've got it set to 0.75 millimeters here. You'll notice that if I change it to 1, it does change the number of top layers. You can see now we've got 8 versus the 1 when it was 1. Next, we're going to be changing our temperature. We want to prevent any clogging or extrusion buildup there. So you can see my settings are saved here, but printing temperature is at 210 degrees Celsius because we are using PLA, and you got your build plate at 60. Probably change that to 55. And then you're good there. Those are your basic settings there that are really going to be all you need to start 3D printing. The software is pretty intuitive, and so if you want to further adjust parts of your build, you can use any of these here. The rotate is the most helpful though. What we're then going to do next is slice. As you can see, it tells us how long it's going to take. So it's a pretty quick build. However, if it were grid, it'd be even quicker. And you can preview your print here. As you can see, these blue here is the supports. As you can see, it's not as dense as the other parts of the print there, and it's very easy to just snap off by hand and then sand where it attached to the print at the end for a nice finished print. Right now we have it in layer view. You can see these areas where we've got our red, which is points of not very much concern, but you can see that there's these places where a little bit more dense and sparse where we need more support, where you've got that green and that yellow. Here's our X-ray view. I don't find this one particularly helpful, but I guess it's kind of cool. And then you would save to disk, and then, or if you had an SD card, then you just put that into the FDM printer there. So that's pretty much all slicing is there. Anyone have any questions while I'm in Cura? All right, moving back to here. So that's our demo. Okay. So you've got your print loaded up now, and it is now time to print. So a couple things to do first. You need to clean and prepare the print platform. Now this could include coating and tape. So as we talked about earlier, that first layer you're going to want to have don't have the fan on so that it adheres to the print platform. Otherwise, when it's extruding out of the printer, when the extrusion multiplier moves up to the next layer and also pulls back in that filament, it could yank up your print with it, which obviously you don't want. So you do need to adhere. However, when that cools, it's going to be really hard to get off if you put it right onto the glass printing bed or plastic printing bed. So what I highly recommend is adding coating or tape. Blue painter's tape works great. I've seen that most commonly. And yeah, ensure that the printer platform is secured. So there's going to be clips for that. It's pretty simple. I have seen times where it's not been secured. And once again, if the extruder filament gets kind of attached to something when it cools too quickly, it can actually pull the whole print bed off, which is quite expensive. So you really don't want to do that. Then you're going to want to preheat the printer. Every printer has its own kind of preheating setting though, but just a 210 for that extruder is probably what you want to do if you're using PLA. Then insert that SD card with your G code on it, and the on-screen controls to set up and start the print. Vary printer to printer, but most of the time it is quite literally just going to be clicking on the print. You've already set all the settings within the G code, so you can just click start. Lastly, before the printer does its proper printing, it's just going to extrude a bit of filament just as it's warming up and making sure it's not clogged. Just remove this, otherwise you're going to have weird blobs on your print, which you don't want. All right, so now it's on to troubleshooting. This is our longer section here. Most of the times where 3D printing becomes most frustrating is the troubleshooting, because a lot can go wrong for something that seems not too complicated right now. So the first one here is if it's not extruding at the start of print. So I just mentioned how at the beginning of print, you should see some dollops of filament coming out as the extruder is warming up. If this is not happening, there's a couple of reasons. So it could be the extruder is not primed before beginning the print. You could have forgotten to preheat it, which obviously you need to do. It could also be that the nozzle is starting too close to the bed. If you've got the nozzle pushing right up against the bed and it starts to extrude filament, that filament is just going to get stuck in the nozzle and then cool, and then you're going to get clogged. As well, the filament could have stripped against the drive gear. So I mentioned that there's a gear that's winding the filament through and out of your printer. There are cases if this gear is turning and the filament is stuck, all it's going to do is make these grooves in the filament. And basically what you're just going to need to do, you can open up the printer. It's very easy to see where the gear is, and just going to have to push that or rewind, push the filament down onto the gear, or you can take out the whole filament and very easily rewind it. It's pretty much just like winding twine along a roll of twine. Lastly, the extruder is clogged, which we will deal with later on how to troubleshoot. So the next common thing is what happens if your print is not sticking to the bed. So this is when your first layer, which again, we've talked about is important for adhering to the bed there. If it's not sticking to the first layer, there's a couple of things you can do. First, strips of tape can be applied to the build platform surface and easily removed or replaced if you want to print with a different material. Peel-Ace tends to stick well to blue painter's tape. If you're using ABS, you could probably use Kapton tape, otherwise known as polyamide film. Many people like to also use things like temporary glue or spray. I don't believe U of T has it on hand, though, in the fabrication facility, but I could be wrong there. If you're doing it at home and something like that and don't have painter's tape, hairspray, glue sticks, and other sticky substances tend to work, but that's kind of a last resort. You're probably going to be doing a little bit more work to scrape your print off of that. Now, the reasons this arises is if the build platform is not level, if the nozzle starts now too far away from the bed, if the first layer is printing too fast, so there's going to be a screen that pops up at the bottom of your printer. It's an interface that you can change things like the print speed on. There is no right print speed when something is printing. It's kind of a trial and error thing there. Temperature and cooling settings should be avoided if you choose the cooling settings and temperature settings that I talked about earlier. And then we just talked about the build platform surface not being sticky enough and how to change that. All right. The next issue is under extrusion. So this isn't a huge deal if you're just doing your very base prototype. But obviously, if you're trying to make something that actually does perform well and strong, as you can see in the diagram, you're going to have these gaps in your layers of filament if the printer is not extruding properly. So this could be a couple of reasons. Incorrect filament diameter. So this can mean if you've used a filament that doesn't match the extruder diameter, which is given with every printer and shouldn't be an issue if you're using the filament provided at U of T. Then obviously you're going to have to get different filament though if it doesn't match. You can also increase the extrusion multiplier like we talked about earlier. Okay, next up here, over extrusion. Printer is extruding too much plastic, which also creates risk of clogging, and it also gets rid of some of that nice clean finish that you see in a lot of 3D prints. As you can see in this diagram here, that's not something that you probably want. Again, this could be incorrect filament diameter. This time you've got a filament diameter too large, or you've got the extrusion multiplier too high. You got to turn that down. Basically, it's doing the opposite of under extrusion. And you'll notice that a lot of these troubleshooting, you can go both ways. You can either over something or under something. And quite often, it's just the opposite to fix it. So next up, you've got gaps in your top layers. So pretty self-explanatory, as you can see in the diagram there. You're gonna have holes or gaps in the top layers you print. Obviously, it's important to have that top and bottom layers of print be optimized, since that is kind of your strongest layer. That's also what's doing basic adhesion and that type of thing. Also, if it's weak at the top, it's likely weak throughout the entire print, which obviously isn't good if you're trying to optimize strength. So this could be a couple things. So not enough top solid layers. So we saw in Cura that you can change the thickness of the top layer. So you could do that. You also saw that you could change the number of layers, and it will manually change the thickness there. So you could have done that. We had 8 when it was 0.75 millimeters. If that happens not to work, although that should work, that is a pretty optimized setting, you could change it to 10 or 12, something like that, and it'll adjust appropriately the thickness of those layers. It could also be that your infill percentage is too low. So, you know, if you're at 15%, you might want to crank it up to 20 or 25%. I've never seen it be too low for 25%. So if you stick in that range there, you should be all good in this regard. If none of that works, it could just be a case of under extrusion, in which case you just need to do those same tips we just talked about. Okay, so stringing or oozing. So this is well, it's similar to something you can see in hot glue guns, where you've got a lot of pieces of filament and little hairs stuck between different sections of your print. There's a couple things you can do to fix this. So first off, the retraction distance. So in general, the more plastic that is retracted from the nozzle, the less likely the nozzle is to ooze while moving. So we talked about how after each extrusion, the nozzle retracts some of the filament. You can change this on that, again, that interface of your 3D printing of your 3D printer. I'm not getting too specific with the interface because it does depend on exact models you're using, but it is pretty obvious. It's basically just like a screen at the front of the printer. So you can change that retraction distance and increase it there. As well, there's the retraction speed, which you can optimize. So if you're retracting too slowly, the plastic will slowly ooze down through the nozzle, and it might start leaking before the extruder is done moving to its new destination. So if you track too quickly, though, the filament may separate from the hot plastic inside the nozzle, or the quick move of the drive gear may even grind away pieces of your filament. And we talked a little about the drive gear earlier. So usually we have a sweet spot for retraction speed. It's between 1,200 to 6,000 millimeters per minute, or 20 to 100 millimeters per second. And that's where you're probably going to be for traction performing the best. And most printers should have that set as their default. There's also movement speed. So you might find that increasing the movement speed of your machine can reduce the amount of time that the extruder oozes when moving between parts. You can check what movement speeds your specific machine is using by clicking on the speeds tab in that interface. And the XY axis movement speed represents the side-to-side travel speed, obviously. And this is going to be frequently related to how much the extruder is spending moving between different spots on your print. The Z movement speed is not as important because that's between stitching layers, and normally you're going to see the oozing in the actual cause of one layer. As you can see, it's that horizontal strings there. It's not going up really. Some machines can't handle moving at higher speeds though. So I would stick with retraction distance and retraction speed, optimizing those first before you move on to the actual movement speed of the printer. As well, a couple of reasons that this could arise is the temperature being too high. Again, shouldn't be an issue if you're using regular PLA. If it is, you're trying on a new filament, obviously make sure that you find the exact optimal temperature for that. And we talked about the other two down there. Okay. So next troubleshooting that could occur is overheating. So basically smaller features are going to become deformed. Obviously you want to avoid, especially if you're printing many small parts, which a lot of things do. So a couple reasons for this could be insufficient cooling time. You're printing at too high of a temperature, or you're printing too fast. So obviously you can change the movement speed. You can decrease the extruder temperature. And when all else fails, it could be just that you're trying to print too many things on top of each other. So try printing multiple parts at once. You can, in Cura, for example, it's say if I wanted to print 2 rings, you don't have to stack them on top of each other. You can just move them wherever on the board there. Or if I wanted to slice that ring in 2, if that was better, obviously I'd have to glue it together, but I can just do that. So that might make each part more optimized and prevent overheating. All right. Next, we have layer shifting. So these become the layers are misaligned and shift relative to one another. So a couple of options here. It could be the tool head is moving too fast. It could also be mechanical electrical issues. It could also be if extrusion, filament being extruded is cooling too quickly, causing the nozzle to get attached to the actual print. And then obviously it's just pulling part of it with it when it moves across a layer. So with regards to the tool head moving too fast, if you're printing at a high speed, the motors for your 3D printer are going to struggle to keep up. If you attempt to move the printer faster than the motors can handle, you're going to hear a clicking sound as the motor tries but fails to get to the desired position. If this happens, the remainder of the print is going to be misaligned with everything that was printed before it. So if you think it's moving too fast, when you hear that clicking, try reducing the speed first by 50%, see if this helps. Again, in that interface that's going to be under process settings and speed tabs, you can adjust the default printing speed and the XY axis move speed. So one of those obviously is the speed of extrusion. The other one is the actual speed of the nozzle moving and tracing out your path. So yeah, if those are still too high, it's going to continue to cause shifting. So you're probably going to have to lower the acceleration settings, which is pretty complicated there. So, and printer specific. So if you get to that point, probably best to consult a technician or a guide online. I've never seen it get to that point though. Usually it is just those first two settings that you can change. Alrighty. Next up, layer separation and splitting. This one's a little bit more simple. Your layer height is probably too large. Again, we've seen how we can change that in Cura there. Probably just reduce it by about 5 or 10 millimeters, or the print temperature is too low. You could probably just increase that by about 5 degrees Celsius. Try again. All right. Next up here, grinding filament. So this is going to occur in that gear drive there. So these other ones you would see on the print bed, this you're just going to hear first. Then you're not going to have any filament extruding. And then once you open it up, you'll see what basically looks like kind of like tooth marks on your filament there. So there's a couple of reasons this could happen. First off, aggressive retraction settings. So first, you're going to check retraction settings. If the retraction speed is too fast, or you're trying to retract the filament too much, so if that retraction distance we talked about earlier is too great, it's going to strain your extruder and the filament's going to struggle to keep up. So that gear is going to be spinning too fast and your filament is just going to keep grinding against it. So if you want to test this, just reduce that retraction speed by 50%, see if the problem goes away. If it does, then you know that it was aggressive retraction settings. If that doesn't work, you want to increase the extruder temperature just by 5 or 10 degrees Celsius. You could also be printing too fast, so you're going to want to change those movement speeds. And lastly, you could have a nozzle clog. So I've mentioned a lot, the dreaded, probably most frustrating troubleshooting for 3D printing out there, your clogged extruder. This one's very painful. Basically, your print has just stopped. You've got filament stuck in this tiny hole of your extruder, which is also very hot. Obviously, you got to stop your print. You got to let it cool down. In some cases, if it's cooled down enough, you can actually just take the part of a filament or like a little screwdriver and just push in through this nozzle down here. I just realized I had the chat open. I think you guys could see that, but I'm not sure. Anyways, you're gonna have to push right in here. And sometimes that will unclog it just fine, but otherwise, you're gonna have to reload the entire filament. And lastly, if none of that works, you're gonna have to detach the entire nozzle. So that just uses a screwdriver or a little wrench there. And this is specific for each printer. I believe the one shown here is an Ultimaker Model 3, but it does depend. And so you're gonna have to consult a lab technician if it gets that far. Hopefully it shouldn't. You should be able to just push the filament out of the extruder using a smaller piece of filament or a screwdriver or something like that. Okay. So if your printer stops extruding mid-print, you're either out of filament, the filament has stripped against the drive gear, the extruder is clogged, or you've overheated the motor, which is a symptom of moving too fast. We've talked about how to address all of those there. Next up, you're going to might encounter weak infill. Obviously, this is important if you're optimizing strength. So this usually happens with grid-based infill. So first step, change it to triangular. Second step, lowering the print speed. And lastly, you're going to want to increase the extrusion width. All right. If you have gaps between your infill and your outline. So basically, when a printer is printing, it's first going to make an outline of your shape, and then it's going to start filling it in, kind of like coloring in the lines almost. Sometimes there's going to be gaps between this, which can cause separation of the entire print, as seen in the photo there. So there's a couple of reasons this could happen. You could be printing too fast. There also could be not enough outline overlap. So that could be due to shift that we talked about earlier. It could also be due to having too thin top and bottom layers, or bottom layers in this case, which we can just change using the Cura settings. All right. If you have curling or rough corners, that is another common thing here. This could likely be due to overheating because the plastic is being extruded at a very hot temperature. If it does not cool quickly, it can deform, right? So it's the same troubleshooting as for overheating. So remember just turning down that temperature and stuff like that. All right, I'm seeing we have some more, someone else who's joined here. So I'm just going to upload the 3D printing aid sheet again here. Here you go. All right, so something that can be very frustrating, and especially if you leave a print overnight and everything looks like it's going fine at the beginning. Many of the other problems you will notice at the beginning. But small features not being printed, that can be very frustrating, and you probably won't notice it till the print is done. This is partially with regards to a slicing issue. It's also just based on filament size and that stuff. It just may not show up if the filament diameter is too large. And sometimes the printer just misses to print them if the outline is too weak or something like that, or if this completely break off immediately. So you're probably going to have to redesign your part to have thicker features, or there's an advanced setting in Cura where you can enable single extrusion walls. Basically, your printer is just extruding once back and forth. Not very strong though. I wouldn't recommend it. I'd recommend having a thicker feature. Or you could, can't do this in MyHall, I don't think, but if you had your own 3D printer or something like that, you could install a nozzle with a smaller tip size for a bit more focused printing. But again, I recommend redesigning the part to have thicker features. Another thing you could do is, if you'll notice with these smaller parts of this comb here, you could flip those horizontally because it's a lot easier for it to print it horizontally, smaller parts like that, and also recommend printing the smaller parts on their own. All right, next up, inconsistent extrusion. So you're gonna have some thin parts of extrusion and some thick parts. There's a couple reasons for this. Filament could be getting stuck or tangled. That'd be on the drive gear, in the actual extruder of the filament or something like that, or due to high stringing and oozing like we talked about earlier. Again, it's those same troubleshooting for those three depending on your situation. It's pretty easy to tell. A couple things you can do if it's not any of those three, or to try it right away, is put your layer height higher. So this arises due to a low layer height. So if you probably have like a 0.25 millimeter layers, not great. If you do 0.75 top and bottom layer, like we discussed earlier, you should be okay. If your extrusion width is wrong, again, based on your filament and the specifications of each printer, obviously that's going to be an issue there because it's going to let more through sometimes less through of the filament. So just make sure that you've got the correct width of, or diameter of your filament matching that. You could also just have, unfortunately, poor quality filament. Again, shouldn't be an issue at U of T, but some filaments are pretty inconsistent and do have some disparities within them. It could also be an extruder issue, in which case that's something you're going to have to consult your specific 3D printer's manual. Alrighty, so we've got issues with support. Support is one of the most important things in 3D printer. And this is something that's very common, is you're going to have these porous surfaces above your support. So you can see on this diagram, these areas which look like almost like these rings. This is where support has been. So there's a couple things you can do regarding this. If you lower your layer height, it's going to make it easier to interface with the thinner support layers, because support, that's all it is. It's a much less dense, much weaker part of the print that is solely there to have something to lay the actual print on top of. So if you're lowering your layer height, it's going to be easier to have that interface between them. You could change the support infill percentage, just making your support stronger. Again, it's not, I wouldn't advise this one too much because, again, it's going to use a lot more of your print, and the point of using support is to just use the bare minimum of print to get the actual overhang eliminated. Otherwise, why wouldn't you just fill in the gap? This could also be an issue with vertical separation layers. This is a setting you can turn down in Cura. If you have two extruders, you could use this, one to extrude support and then one to extrude your main filament. This is also going to decrease the cooling time between each, between applying those layers, and just make interfacing better, although the liberty of a second extruder is not something many of us have. As well, a little bit more about our support infill percentage. So we talked about using 25% for regular infill percentage. Usually support uses around 20 to 4%, but its density is lower there. You could increase this above 40% if you wanted to, if you notice this early on. If you do it later on, your support's just going to become top heavy and not be effective. It's just going to fall over. So you got to notice that early on to do that. Vertical separation layers is a setting in Cura, like I said. It determines how many empty layers are left between the support structures and the part. If you're printing your support structures with the same material as your part, which you're going to do if you have one extruder, it's common to use at least 1 to 2 vertical separation layers. If you use 0 and you're printing everything with the same material, the support's going to bond to the part and become difficult to remove, but that can just be sanded off. So it's not a huge issue there if you want to set your vertical separation to 0. Another cause of this can be the horizontal part offset. So this is another setting. It controls side-to-side distance between your part and the support structures. So vertical separation layers, they help keep the top of your supports from bonding to the bottom of your part. Horizontal offset will keep the sides of your support from bonding to the side of your model. For this, you're going to want to use a value between 0.2 and 0.4 millimeters, but you're going to have to experiment and optimize this perhaps. All right, that's it for our long troubleshooting section. Arguably the most important part of 3D printing there. Does anyone have any questions about troubleshooting? There is a troubleshooting guide that I've linked at the end of this presentation as well, if you want to read over this. I know it's a lot just hearing me discuss how to do it. No questions. Excellent. Okay. On to, so you've printed your print. Woohoo. And you've done all the troubleshooting and it looks like you have a successful print. What to do next? So first off, wait for that print to cool. It would really suck if you made a great print and then you tried to pry it off when it was still warm, and the top layers just completely shifted or deformed. That'd be very frustrating. So please wait for it to print to cool. Chances are, if you're printing something that's larger than the ring I looked at earlier, it's going to be like 2 to 3 hours, sometimes 6, sometimes 12. So just wait an extra 20 minutes. You've already waited 12 hours or 6 hours. Let it cool. Removing the print from the platform, you might need tools for this. You can use just like a chisel or something like that. Or even like, I mean, I've seen people use spatulas, but probably a chisel is best there. If you want to clean up and remove supports and extruder priming materials, again, supports are very easy to break off by hand. Just be careful if you have thin parts of a print, like in that comb we saw earlier in the issue with small parts of printing, those can break off pretty easily if support is attached to them. So just make sure that you're being careful with that. And then again, you can sand and clean up those areas. If you're using ABS, you can use acetone to smooth it out. And some labs have 3D printing pens or resin filling pens that can smooth out any holes in your printing. This is obviously just going to happen because you are putting layers of filament on. It's obviously not going to blend perfectly. So if you want to make it look a little bit nice, you could sand it, or if you have a 3D printing pen, you can use that, although those aren't particularly common. A couple last safety precautions before you start 3D printing. Remember, the hot end is going to be heated up anywhere between 210 and 245 degrees Celsius. And the platform is going to be anywhere between 50 and 110 degrees Celsius. So just be sure to watch your hands there. And obviously, when troubleshooting, wait for them to cool down and stop your print. You don't actually have to turn off the whole thing. You can just click stop on the interface. As well, the cooling fans are often exposed and they do rotate at high speeds. So if you're doing anything regarding going around the back of the computer, which is what you will be doing to spool filament and all that stuff, just be mindful of the cooling fans there. As well as stepper motors that move the extruder in an FDM printer are also heated. So again, watch out for those, as well as the control board and the actual drivers of those motors. And lastly, if you're trying to pry your print off of the board with a spatula or a chisel, you might have to apply quite a bit of force, so just be mindful of your hands there. All right, some additional resources. Again, this is the troubleshooting guide. It's going to have a lot of summaries of what I've said here. Probably best to, if you're going into 3D print, just have that bookmarked there, because if you run into something that's super, super helpful, I use it a lot. And lastly, if you want to download Cura, it is free. And it's just that link there. Any questions from anyone? Awesome. All right. So just reminder, as Shahir talked about earlier, we have a couple upcoming events. That's it. This is our last workshop for this semester, but we'll have the Designathon next semester, the Autodesk Glider competition, and a couple of Autodesk Run workshops. Thank you for attending the workshop.